right, good morning, everybody. Today is, I'm not even sure. Today's Wednesday. Yes, it is. It's Wednesday, March 18th, 2015. And this is Before the First Cup of Jules here on UCY.TV. Good morning, everybody. Happy Wednesday. I don't know what I thought it was. I wasn't sure if it was Tuesday or Wednesday or maybe even Thursday. But no, not lucky enough. It's not Thursday. I was bamboozled this morning. I opened my eyes and it was sunny out. My nose is feeling a little stuffy, like it's spring in the air as the allergies get into full swing. And I was pretty happy. So I came out here, opened up the door. Feels pretty good. Fire up the phone and look at the thermometer. And it is 27 degrees and light snow. Now, weren't we done with that? I guess there's another polar vortex coming. So, we'll see. This weekend's supposed to be really cold again. I've had enough. I'm just too tired to even argue anymore. All right. So, yesterday, we had a special guest, Mr. Brandon Turville. We spent the full hour, and then remember, I continued on hour 2. Something that was a bonus clip. You will never see that in the archive just because of the recording, the way the recording's set up. Since it wasn't my time slot, that did not get sliced and diced into my archive, and honestly, it's fine. I probably have 10,000 hours worth of audio stuck here and there, so that's okay, but hopefully you got the bonus. Yesterday was fun. Thank you very much, Les, for calling in. That was great to have a phone call. I usually don't get phone calls or a second hour, so it was all good. But yes, we had Brandon on yesterday. We talked about Russia, Ukraine, Syria, and Iran. And we mentioned Israel. I saw Bibi won again. They said it was by a very narrow margin. I know that until late last evening, they were still counting. And then Netanyahu finally came out and declared victory. But guess what? We're not talking about any of that stuff today because I had been on a bender for weeks on end, but I had started on something yesterday that I really, really wanted to continue on. Leslie had called in and asked about nanotech. We'd spent a lot of time on nanotech, but while I was working on something completely different last night, one of my suggested videos down the side of YouTube came out with something that I had never seen before. I did not know who this gentleman was. I'd never seen this interview. And when I watched it last night, I sat there literally with my mouth open. That doesn't happen too often. My mouth open and me silent. Nah, not my world. It doesn't, but I did. And I think I need to share this with you because a lot of our questions were answered. Like this looks like it's around the same time period, this interview, as the one that Kurzweil did with Eric Drexler. We listened to that again 2 days, or was it yesterday? Actually, it was yesterday in part 2 of the show I wasn't expecting to do. I played you that clip, I think it was 18 minutes, the interview with Eric Drexler. Well, there is another interview. Looks like Kurzweil's same show, whatever show that was, same series. He looks about the same age. And I thought I heard this guy say something about it being the 90s. So I don't know if these took place in the late 90s. I wish I did because he talks about Robert A. Freitas Jr. is his name, and he looks like he must also be an attorney because he's got a JD that follows his name. But he's a senior research fellow, nanorobot theoretician. He's written all kinds of books and does all kinds of research and seems to be pretty influential in the field. But Kurzweil interviews this guy, and they start discussing the future of nanotechnology. And he also knows Eric Drexler personally. He read Eric's books. And then Eric really wasn't working on anything for the medical establishment and ideas for nanotech in the medical technology field. So that's where this guy jumped in. And I got to tell you, I think you need to hear this. I mean, I hate just sitting back and playing like half-hour clips, and maybe what we'll do is we'll take each section like we did originally with the first interview we heard the first time from Drexler, and we'll break it up. So, when they take the breaks in between sections, I'll pop in and make some commentary. But I really think you guys need to hear this. I'm going to read a little bit about this Robert A. Freitas, Freitas, senior research fellow at the Institute for Molecular Manufacturing, a non-profit foundation and world leader in a molecular nanotechnology research. Former research scientist at Zyvec Corp, the first molecular nanotechnology company, has briefed NATO, the U.S. Senate, the U.S. military agencies on potential molecular nanotechnology applications, has published 33 refereed journal publications, 4 books, 60 other publications, and several contributed book chapters. Co-edited the 1980 NASA feasibility analysis of self-replicating lunar space factories. Published the first ever medical nanorobot design paper in a biomedical journal. And authored Nanomedicine, the world's first textbook on possible medical applications of molecular nanotech and hypothetical medical nanorobotics. It was at the time hypothetical. Awarded the Lifeboat Foundation's Guardian Award in 2006 for proposing solutions to the dangers of advanced technology. So this must have been at least 2006, this video. So, well, that's good, because at least it looks like it's recent. But then I guess in looking at Kurzweil, he must have been using greasened formula. I thought he was a little greener than that, or grayer. This Robert Freitas was also the first to file a patent on diamond mechanosynthesis. He's talking about these little nano diamond robots, diamond nanorobots. He also co-founded the Nanofactory collaboration with Ralph Merkel, a research program to develop the first diamondoid nanofactory. I'll let a little bit of the cat out of the bag. So one of the things that Kurzweil asks him as a question toward the end of this is, what happens if these get out? And how are they going to stop us from being invaded by nanorobots? And his answer is highly disturbing, but that's not until the end. But guys, I mean, we've already listened to part of this series of interviews. Like I said, I didn't realize that there was anything more in this series, but it appears that there is, and you really need to listen. So, all right, let me connect up really quick, and we will do a running commentary. And I have so much other stuff. I mean, it's all kind of related to talk about. So if we have more time, we'll dig in. If we don't, we'll just make this the rest of the week, because, hey, it's still not spring. Not until Saturday, I think. All right, there we go. It's all set up. All right, so this is Ray Kurzweil and Robert Freitas discussing the future of nanotechnology.
Eric Drexler talked about nanosystems 20 years ago and laid out a vision of what nanotechnology ultimately could be. What progress have we made in the last 20 years in verifying and confirming the basic foundations of that theory, and also in terms of actual practical parts of that vision having been put into practice?
I think in the last 20 years, Drexler's theories have been confirmed to the extent that we've been able to test them. So far, nothing that he wrote in Nanosystems has been shown to be wrong of any substance. On the theoretical side, we have progressed to nanorobot designs. We have many nanorobot designs. We have many machinery designs. We have designs of devices which have, I think the last one was 25,000 atoms. It's a very large, complicated gear structure. In the 90s, there were many designs for bearings and gears and small manipulating devices and various parts that had several thousand atoms. So we're starting to get a good library of nanoparts built up. We haven't gotten anywhere near the point where we're doing the system integration on them yet. But slowly but surely, we're putting the pieces together of doing the design work. There have been a number of experiments where atomic force microscopes have been used to do pick-and-place operations on individual atoms, particularly hydrogen atoms and carbon monoxide molecules, which is just a carbon and oxygen atom. And there has been one notable experiment done in 2003. It was the first time mechanosynthesis has ever been done in the laboratory, which is purely mechanical chemistry done at a tooltip. And it was a silicon atom. And they pushed a silicon atom down on a surface, and it is stuck, and they pushed it again with a different force, and it came off. And so we know that we have a proof of principle that mechanosynthesis should work. Now we just have to finish designing the tooltips and then build them experimentally and test them.
Is there some idea of a roadmap from where we are today to actually making these nanofactories feasible?
Well, my colleague Ralph Merkel and I have started something called the Nanofactory Collaboration, and we have approximately 24 researchers who are participating in it. And we're starting with diamond mechanosynthesis, but the long-term goal is to work toward all the components you would need to be able to build a working desktop nanofactory. We've estimated that if we had proper funding and proper focus on the objective, the time would take approximately 16 years for the entire development operation. I think the 2020s will be the decade of the desktop nanofactory, and the 2030s will be the decade of the nanorobots. We might see a few nanorobots coming in at the end of the 2020s, but I think the 2030s will be when they are deployed medically in a large way and start to displace most other forms of medical technology. Well, I guess the ultimate start of nanotechnology was roughly 1906 when they first proved that atoms existed. It's hard to believe that only 1 century ago there was debate about whether atoms existed. There was no experimental proof yet that they definitely existed. So we've only known that for a century. After that, I suppose Feynman's room at the bottom talk, where he laid out for the first time the possibilities of building very, very small machines, But it wasn't a serious scientific discourse. It was a dinner talk, and it was sort of left to Eric Drexler to put everything on a more technical basis and put some numbers to it and establish that this stuff was actually feasible, that you could build structures atom by atom and make machinery at that scale, and that it would work. In the 1980s, I did a study with NASA on self-replicating factories on the moon, and we worked out a design for that. And we had looked at how to do it with microscale technology, with things that were microns in size. But we never thought about going all the way to atoms. And I read one of Eric's books. Actually, it was his most popular book, Unbounding the Future. And I looked at it and I said, wow, this is great stuff, but he's being so conservative in this book. Well, I found out that was because he wasn't conservative in his other two books, in particular Engines of Creation, where he laid out a lot of detail about the applications, and Nanosystems, which is just a fantastic technical book, which laid out all the technical details. And once I saw that, I realized that the best and highest application of nanotechnology would be the medical applications. I immediately contacted the Foresight Institute, and I said, is Eric writing a book on the medical applications? And they said, no, he's doing other things right now. I said, well, I guess I'll write that book. So that was sort of how I got into it. Writing a 3-volume set, which has now it's going to be a 4-volume set on nanomedicine, and writing a book on replicators, and I'm also writing a book on diamond mechanosynthesis. So I'm just I'm trying to make Eric's visions a practical reality. Since then, there have been a number of theoretical advances and experimental advances leading toward the working out of that technology in a practical sense. And the ultimate goal of that is to build nanofactories and ultimately medical nanorobots so that we can all have very long, extended lives.
Oh, very long, extended lives. That is the reason why we're doing this. All right, I have this annoying echo. So let me just shut up and play this some more.
So when people think of a factory, they think of a big building, but these nanofactories will sit on a tabletop, right?
That's correct. Sit on the desktop.
They're going to be placing and positioning molecules and molecular fragments and even atoms, but obviously not one at a time, trillions or more at a time. How is it going to scale up to be so massively parallel?
Now, these tools, you have one tool operating at a time, but on a particular reaction. But you have many independent production lines in the nanofactory. You might have millions or even billions of separate production lines. And in each production line, you have a tool which is doing an operation, a particular chemical reaction, building a particular part of a nanopart that you're building. So many of them are being processed in parallel.
So just like on a chip today, you have billions of components. These nanofactories, which will sit on a tabletop, will have billions of little processes going on.
Exactly, and they'll have billions of processes going on at each scale. There will be some going on at the nanometer scale, and then there will be parts which are composed of 10, 100, even 1,000 atoms, and they will be feedstock to the next process, which has larger assembler arms, and they will be grabbing them and feeding them to still larger assembler arms, all the way up to the macro scale. At the highest level of the factory, the robot arms inside will be picking up parts and assembling them into larger parts. And the larger parts will then become parts of the nanorobots.
Can we, as an intermediate step, harness biological systems like a bacteria or some other type of cell which has a lot of capability and add non-biological materials to it, motors, computers, to have a hybrid biological, non-biological system?
Oh, evil laughter. I need to stop this echo. Kurzweil, did you hear him? Is it possible? Like, Kurzweil just, if anybody had a red button issue, Kurzweil and his transhumanism, I've just never seen anything like it. But the way he asks this question, and they're always so pointed, and he's like, can we harness a biological system where we can insert, like gears and motors into something and basically hijack biology and utilize it for our own synthetic means? And, if you heard this, Robert Freitas, in the last section or so, he had talked about the replicators. That was kind of one of the things that he's written about, is not only using these at an atomic level to build things and use them as replicators, and how to get your hands on, I'm going to sneeze, excuse me. Yes, it's allergy season. How to get your hands on raw materials, how to start building your next generation nanofactories, which, by the way, they talk about in here, like we were talking about yesterday, how what is coming is unlike anything we've ever seen before. This is not just some newfangled technology that's going to make it, easier to keep the house clean or easier to keep yourself healthy. We're looking at a paradigm shift. We're looking at a disruptive technology that is going to take us into a new age. And like I said yesterday, we had the genome was pretty much, 20th century. But it's fueling now this whole revolution that's happening in the 21st century, and I think they even mentioned that 21st century is going to be known as the century of nanorobotics. This stuff horrifies me. They talk about, too, coming up here in a little bit, Kurzweil actually asks about this gentleman's beliefs or thoughts on self-replication versus they talk about injecting nanobots and things that they'll go do inside the body. And Kurzweil asked him about his thoughts about self-replication of the bots, so they live inside you forever and reproduce. And this dude has some pretty interesting responses to that because he is not so in line with the rest of the establishment on whether or not self-replicating nanobots should be released into the wild. And while this is playing, I will find that clip. I saw it yesterday of, thought it was Ben Swan, but maybe it wasn't. But it was, pretty sure it was RT, came out talking about the new self-replicating nanobots to treat cancer. So we'll have to see about that. That's a scary thought. All right, so let me connect again. That annoying echo is coming back. All right. Oh, it stopped. Okay, let's listen to a little bit more of this.
I believe that's possible. What there has been a lot of work on recently is biorobotics, which is re-engineering individual bacteria. And you treat the genes as cassettes, and you can switch new ones in and take the old ones out and basically make them do what you want them to do, secrete new materials and that sort of thing. They've been able to take bacteria and engineer enzyme networks inside of them that are keyed to other molecules which fluoresce. And when you look at them under a microscope, you can actually see the lights twinkling. So they can make computer components like adders and half adders and things like that to do simple logic. The problem with that is biological components are inherently slow, and they're not as reliable as using purely mechanical components. When we are able to build with Diamond, we'll be able to build rod logic computers and very, very rigid systems that will do exactly what we want with a minimum amount of error.
So you mentioned red blood cells. A more complicated type of cell in the bloodstream is a white blood cell. What's the feasibility of creating basically robotic immune system cells, like T cells, and that would augment the immune system?
Yes, we could create artificial white blood cells. I've designed one on paper. It's called the microbivore. It would have...
I have to stop leaving my mute on. All right, so he's created the microbivore synthetic white blood cells. Here it comes. All right, a little bit more.
Of more atoms than the respire site, about 100 billion atoms, a little bit more than 100 billion atoms in the microbivore. And it would be put into the bloodstream, probably about several billion of them, and they would go through the bloodstream and they would look for bacteria that they've been programmed to detect. And like flypaper on their surface, the bacteria would stick to the surface. And then the bacteria would be transported into the mouth of the device. And inside the device, the bacteria would be digested. And then the remains would be harmless sugars and amino acids that could be put out into the bloodstream with no problem. And this entire process of digesting the bacteria would only take about half a minute. Now, a natural white cell takes about 100 times that long to completely digest a bacteria. So again, we have a situation where the medical nanorobot is 100 to 1,000 times faster or more effective in some way than a natural biological system.
Yes, people are so obsolete. Did you hear that? So they're going to make these what did he call them? Not microphages. Oh, damn it. Hold on one second. We're going to go back and hear that again. Because it's really a scary thought. So just like a white blood cell goes in and searches and destroys foreign invaders, this is going to be a synthetic version of that when it finds whatever has been programmed to find, in this case it happens to be some evil bacteria, but I mean, who's to say they couldn't program it to go Go search out your proteins, or go search, you know, like autoimmune disease is your immune system turning on your body and attacking parts of your being that really are supposed to be there. And that's what causes the autoimmune disease. It attacks it as if it is a foreign invader. What would happen if, intentionally or unintentionally, these, what the hell did he call them? Hold on.
The bacteria would stick to the surface.
Get back up just a little bit more.
Oh yeah, here's well, sir. Okay.
Immune system cells, like T cells, and that would augment the immune system.
Yes, we could create artificial white blood cells. I've designed one on paper. It's called the microbivore. It would
Microbivore. That's what it is. Not an herbivore, not a carnivore, but a microbivore. Some new creature designation. And I mean, hey, biological life, man, we're just too slow at it. So these new robotic microbivores could gobble things up in 1/100th of the time. You'd be cured in minutes. All right, we're going to continue now. I'm going to just let it run from here and go a little bit further.
Have more atoms than the respirocyte, about 100 billion atoms, a little bit more than 100 billion atoms in the microbivore. And it would be put into the bloodstream, probably about several billion of them, and they would go through the bloodstream and they would look for bacteria that they've been programmed to detect. And like flypaper on their surface, the bacteria would stick to the surface. And then the bacteria would be transported into the mouth of the device. And inside the device, the bacteria would be digested. And then the remains would be harmless sugars and amino acids that could be put out in the bloodstream with no problem. And this entire process of digesting the bacteria would only take about half a minute. Now, a natural white cell takes about 100 times that long to completely digest a bacteria. So again, we have a situation where the medical nanorobot is 100 to 1,000 times faster or more effective in some way than a natural biological system.
And presumably you could program these or even download software to combat a whole variety of different pathogens, perhaps ones that our natural immune system was not evolved to deal with.
That's right. The microbivores could be programmed to deal with any type of bacteria whose antigen signature was known. It could even be programmed to deal with ones that were created artificially for nefarious purposes, or ones which had evolved in some obscure part of the world that nobody had ever seen before. As long as you know what the bacterium looks like on its outer surface, you should be able to program a microbivore to detect it and dispose of it.
Wow, so he did work with NASA in the 1980s on self-replication factories to build stuff up on the moon. And now he's talking about these, I can't remember what they're called again. It's before the first couple people. Microbivores that you could build with your nanorobots to go in. And as long as you knew, he says, it'll take, you could program it, download software to identify any invader that you want to program it for, even those that could have been built for nefarious purposes. So as we see all of this crazy, these crazy infections, the Vacker drumbeat beats louder. We have Department of Homeland Security making us afraid, be very afraid of whatever the next outbreak is going to be. And all of this money and research and time and effort going into precision medicine and nanotechnology and even Google talking about and having a lab with 100 doctors working on nanotech and this doctor under the skin running in your blood all the time. I mean, guys, they literally, the gig is up. This is happening. They even talk about, this is your longevity. You can live for hundreds of years. I mean, Kurzweil is just like, you should see him in this interview. He's just so excited. He got an interview with this dude, and they're working on this stuff. All right, here, a little bit more.
What about viruses and cancer cells?
A version of the microbivore which had more mobility than the one that travels through the bloodstream would be able to go through the tissues and look for tumors. It would recognize the tumors the same way that it would recognize bacteria by the cellular antigen structure. And it could digest the tumors right on the spot. So essentially, a microbivore class nanorobot would be able to dispose of cancer quite easily.
And, that's what we said. They're going to sell us the cure for cancer. So these new microbivores that they're envisioning wouldn't even be in your blood. They'd actually go through all your cells and search for tumors or whatever else they told it to. Now, hold on, because this is where I want to jump off for 1 second. This was the story that came out February 3rd of 2015. It was RT News, but it was not Ben
After
Swan.
decades of research and development, medical scientists have announced that nanorobots capable of isolating and eliminating cancer cells could soon be ready for human testing. But it's the way it works that's truly mind-blowing. Now, check this out. Researchers at the Weiss Institute at Harvard University use a technique called DNA origami, and that's represented here by these ribbons. The robot is essentially made up entirely of these synthetic DNA strands. And when left alone, the strands then self-assemble. After all, they've been pre-programmed by engineers to assume a specific shape for a specific mission. And
now, this whole self-assembly question, we haven't even gotten to that yet with this interview, but the self-assembly is what this Weiss Institute has been working on, and I mentioned them. That is the RoboBees division, where the RoboBees and many of these other unmanned micro drones that they've been building, more robots, have been coming out of. There's all kinds of funding there. There's DARPA money sprinkled. This is not cool, and I want you to hear this interview in his opinion about the self-replication. There's a huge danger here.
in this case, that shape is a simple cylinder with two open ends on each end held together by a DNA lock. Now, the lock can only be opened through a corresponding molecule or protein, much like a standard lock and key. And as you can see here, once this happens, the robot flings open to reveal its payload. And in this case, again, it might be a cancer drug that's then administered to the patient. Dr. Ido Bachelet, a leading researcher in the field of nanorobotics, explains how this works.
Nanorobot is capable of recognizing a small population of target cells within a large population of bystander cells, which should be left alone. And the way it does that is that while all cells share the same drug target that we want to attack, only those target cells express the proper set of keys that open the nanorobot, and therefore only they will be attacked by the nanorobot and by the drug.
Again, like I said, yes, they can target specific cells, or they can target specific environments for it to look for. But who's to say? I mean, how many times do we have software glitches? Who wants to be 1.0? I'm not lining up for this, and neither should you. There are going to be lots of people who line up for this because this is the promise, but I'm telling you, it's the dangling carrot. Remember, the dangling carrots are what control us. And there will be enough dumb people that will just lunge at the dangling carrots.
So let's recap a little bit and take a closer look at this nanorobot. Now, remember that this structure is made entirely of synthetic DNA, but it's fully biocompatible with the way the human body works, meaning that not only can the robot be programmed to do a job, it can break down and be expelled naturally when that job is over.
And that is what they do discuss here coming up, is how you cannot have them self-replicate inside the human body because there will be a massive danger with that. They can self-replicate to where you are manufacturing them, as in self-replicating manufacturing, which is what happens. But once they are within the human body, if they are going to reproduce within the body, they are going to have to use the body for natural resources. And you don't want these nanobots using you for food, okay, to power the processes. You can create them to repair themselves without having to procreate, hence not requiring any type of fuel to continue. You know, they can be programmed with whatever their energy sources, maybe even using kinetic, I don't know, or blood flow. I don't know exactly how they're doing that or giving it fuel. But in the discussion, they talk about that, but you do not want them to replicate. They will become a new living entity if they could do that. A synthetic entity, mind you.
But what this monumental step in medical science represents goes much farther than treatment and rehabilitation, to include diagnostics as well. According to Dr. Bachelet, nanorobots can already identify at least 12 different types of tumors. And in the near future, these bots might be more like microsurgeons, injected into our arms as part of routine checkups, scanning our bodies and attacking disease cells before disease is even discovered. Needless to say, the future applications of this technology are endless. Manuel Rapalo, RT Studios, Washington.
Yeah, if we had like benevolent overlords, I would say it's an amazing technology. But we don't. We have evil crazies that want to rule the world that have all turned into and have been groomed into narcissistic psychopaths. All right, here, I don't know if we're going to be able to finish all of this, but let's continue and get as far as we can. So we're going back now to the interview with Ray Kurzweil and Robert Freitas about the future of nanotechnology. So that video I just played from RT was from February 5th of this year. So even if, I mean, I think that the most recent reference I saw in this video was 2006. So, I mean, hey, maybe we fast forward now 9 years and here it's ready for human trials. All right, here we go.
How about atherosclerotic plaque?
Nanorobots could also be used to combat arteriosclerosis. I would use a nanorobot called a vasculocyte, which is a small device that has lots of little legs on it, and you inject it into the bloodstream. It collects in the capillaries and forms up into traveling rings that then walk back up the vascular tree until they reach the site of the arteriosclerotic lesion. They then form up into a bandage and perform repairs. Another nanorobot called a chromelocyte would be the first true cell repair machine. Chromelocyte is also a very small nanorobot. It would be put into the body. It would travel through the tissues into your cell. Inside the cell, it would travel to the nucleus. It would there change out the chromosomes that are in your nucleus.
Oh, wait, are you hearing this? I mean, we're talking nanorobots to go at a cellular level and start swapping things out of the nuclei of the cells in your body.
And replace them with newly manufactured ones that had been corrected, with all the defects in them corrected the way.
Hey, you won't have to be a broken biological human anymore. You can be one of Kurzweil's army.
You want. It would then remove itself from the body, and the old genome would then be disposed of.
Disposed of? Holy crap! See, that's what I'm worried about. You know, I was thinking evil thoughts, but when he was talking at the very beginning, talking about his nano diamond factories, I was like, oh yeah, nano diamond factories for the billionaires who are going to be the biggest winners in the end of this quote unquote longevity project that's happening in the global petri dish.
So this is a key technology because it'll allow you essentially to roll back the clock.
One idea that I wrote about was to actually replace the nucleus itself with a little nanorobot that would basically act like DNA and actually include the ribosomes and be able to produce amino acid sequences that would then be folded into proteins and so on. What's the feasibility of something like that?
It might be possible to create a nanorobot which would entirely replace the functions of the nucleus. I think it would be technically possible. Whether it would be advisable, I'm not sure, because...
And Kurzweil's going, damn, that was my merging with the machine. Replace my biological guts to my nucleus with all synthetic, and I could upload myself at some point in the future. I don't know. When I see Kurzweil and I just see how excited he gets about this stuff and he gets like this really creepy look on his face, you know. So when he has an expert, somebody who's in the biz, who tells him that they don't think that's such a good idea, it gives me pleasure. All right, here we go.
As a general principle, I would prefer to put nanorobots into the body, have them do their task, and then remove them. If you leave nanorobots inside the body for a long period of time, you get a number of other issues, biocompatibility issues, reliability issues. One of the nice things about biology is it is good at self-repair. A nanorobot, unless you give it the ability to self-repair, will not be able to do that, and eventually it will break down.
My vision is we can begin to actually replace biological systems with engineered systems.
Yes,
There we go.
I have actually, with Chris Phoenix, designed a nanorobot system called the Vasculoid. And what it is, it's a replacement for the entire human vascular system.
What?
What it does, it's essentially a coating of nanomachinery over the entire vascular surface within your body. And materials are transported via a ciliary transport system with the materials like oxygen and carbon dioxide and nutrients and things like that transported in little containers. And this would essentially replace 9% of the volume of your body with nanomachinery.
What?
At some point, we start getting into the questions of what does it mean to be human? What is human? If you have 9% of your body replaced by machines, are you still a human or are you something else?
And Kurzweil's going, yeah, we're transhuman. That's the point. 9% of your body replaced with nanobots.
You mentioned the possibility of nanorobots augmenting our natural immune system. But what about our immune system getting in the way? Would it react negatively to the intrusion of billions of these nanorobots in our bloodstream?
If we just put nanorobots made of diamond into the bloodstream, the biological system will react. It will react by depositing proteins on the surface. It will react by attempting to phagocytose them, which means a white cell will try to eat them and cart them off to a lymph node or somewhere else in the body.
Right, because it's seen as a foreign invader.
And we don't want that. So nanorobots will also have to have various biocompatibility systems. And these will make them invisible to the immune system and will also make them unable to be captured by white cells.
You mentioned nanorobots going into the brain and actually interacting with our biological neurons where they could monitor or influence the activity that goes on in the brain. And
Monitoring and influencing our brains. Yeah, that's what I'm talking about.
these will be computerized, so that introduces the concern about software problems like software viruses or software that would monitor what's going on in your brain or actually influence it. So how do we deal with that if we actually have software on nanorobots in the brain influencing what we do?
Influenced by the alphabet agencies who get their hands on the code and can upload the newest spy software.
I think we're going to need, to avoid software glitches, we're going to need very strong laws prohibiting that sort of thing.
Oh, right.
We're going to need very good software engineering to prevent that sort of thing. We're going to have a lot of experience dealing with that beforehand because we're already building bionic equipment that people are using, artificial arms and things like that, which have chips in them. And that sort of abuse is already possible, and I'm sure there will be cases in the future where that happens long before we get to nanorobots. I expect that by the time nanorobots are deployed, which will be sometime perhaps in the 2020s or the 2030s, we will have a whole set of laws in place, regulations. There will be things you can and cannot do, and that's how we will deal with that.
And the 2020s, remember, people, that's only 5 years away. And if they announced in February of 2015 that they're going to start the first human trials on nanorobots in the blood to combat cancer, we're already there.
Now, of course, the quintessential concern with nanotechnology has to do with self-replication. And, of course, we know self-replication is a big problem in biology. Most disease has to do with self-replication. Bacteria, viruses, our own cells, in the case of cancer, prions, self-replication.
Prions, also, mad cow disease, causes.
Causes disease. Nanorobots are inherently much stronger than biological systems being built of diamondoids. So if they self-replicate, that disease, quote unquote, could be even a tougher problem than biological disease. So first of all, what's the feasibility of self-replication in in the nanotechnology world?
I think it's possible to build self-replicating nanorobots. Whether that is the way we'll actually build them or whether we will use nanofactories to build them is up for discussion. It's probably safer to use nanofactories to build nanorobots. There certainly possible for them to be able to replicate. As a general principle, you do not want to put self-replicating nanorobots inside the human body.
Did you hear that? Well, let's find out why.
I suppose not everybody agrees with me on that, but that is the way I think that we can best guarantee safety. If the nanorobots are able to replicate inside the human body, that means they are using some component of the human body as food, and we don't want them to be doing that. We want them to be going in and performing a therapeutic task and then coming back out again. Even in the case where you have an augmentation scenario where you're permanently installing nanorobots inside your body, you
permanently installing.
You would still, even if you had them able to repair, you wouldn't want them to be able to reproduce. For the very reason that you described, they could get out of control, somebody could hack into them, and there just is no need for that capability.
So if there's, let's say, nanofactories can take an information file and create an entity, and if one of those entities that could be created, or one type of entity, is a self-replicating structure of some kind, then that would be a very dangerous file to create. How do we prevent a terrorist or someone who's bent on destruction from creating such a self-replicating system, given that
Good question, Kurzweil.
that responsible practitioners will follow the ethical guidelines, but irresponsible ones won't?
Forestalling abuse of nanorobots in terms of building replicators, that has to be dealt with on many levels. One level, of course, is simply putting controls in the factory itself. And there are many ways to do that. Certainly the digital rights management technique is, some people don't like it, but it would certainly go some distance in that.
Digital rights management, do you hear that? Ding, ding, ding. It'll save us all from self-replicating nanobots in our replicators.
Another way would be you would simply download the software from a central source, and that central source is very tightly controlled. So you could also use materials inside the nanofactory which were difficult to get, like we call them vitamin parts, and then restrict the supply of vitamin parts.
That's what they're doing in our bodies.
Inevitably, in the future, there will be some acts of abuse. There will be some terrorist acts because that's what humans do, unfortunately. So what we're going to be needing in this era of nanofactories is something equivalent to the fire department. And we have fire departments. They range all the way from a small fire extinguisher in your kitchen when a grease fire comes out of your pan to a couple of engines that respond to a house that's burning on your street, all the way up to massive forest fires where thousands of people are brought in and huge amounts of equipment are brought in from government stockpiles. And I think we'll have a similar response scenario with nanorobots. Hopefully the incidents will be very few, but we will have an emergency regime which is set up to deal with that type of event. And according to how severe it is, the appropriate response will be made. Along with that, we will need a surveillance system of some type to detect the activities of unwanted replicating nanorobots.
Yes, we're going to have some sort of response team to respond when things go out of control and need to be neutralized.
And we can do that. We could have satellite surveillance looking for heat signatures because nanorobots generate heat when they work. And there's a number of other things that we've looked at that could be done to detect the threat and then respond to it quickly.
Now, the most daunting scenario in terms of the so-called gray goo attack would be a two-stage attack, a stealth attack, where the first stage, the biomass is sort of seeded, let's say at 1 per 10 to the 15th power. So it doesn't create a heat signature that you could detect by a satellite because they're very few in number, but they're all over the place. And then when they start self-replicating in place, it would only take some 90 replications or some limited number of replications to then destroy the biomass. And you don't have this moving front of destruction that you could detect. So
it would only take 90 replications to destroy whatever the biological entity it's going after. Now remember, they're talking about surveillance and how to find out-of-control nanotechnology.
What's the feasibility of that, and how do we deal with that spectrum?
So when you contemplate possibilities like that, you need to have more than just monitoring of heat signatures. What you need to have, and this is one of the other things I was mentioning that I alluded to earlier, was that you need to have a method of sampling the environment on a regular basis. So we will
ding, ding, ding.
Send out devices which will constantly be sampling the dirt, the air, the trees, in some cases even living things, and
the people,
and examining what nanorobots are there, characterizing them, and reporting them back to some central monitoring agency.
There you go! I told you, we are being enslaved at a cellular level. They will be monitoring everything and reporting it back to a central surveillance arm.
So that we will have a good picture as to which nanorobots are where and what they are doing and who is in control of them and who their manufacturer is and who is legally responsible for them. And this sounds like a massive amount of data, but when you consider that we're going to be able to build a computer that will have the computing power of the human brain, that will have the volume of a bacterium, we really are going to have that type of computing power available to us in the 2020s and 2030s, which is when we would be thinking about starting to deploy this type of a system.
Wow. Wait, what? It was the size of a bacterium, but the computing power of what?
You need to have a method of sampling the environment on a regular basis. So we will send out devices which will constantly be sampling the dirt, the air, the trees, in some cases even living things, and examining what nanorobots are there, characterizing them, and reporting them back to some central monitoring agency, so that we will have a good picture as to which nanorobots are where and what they are doing and who is in control of them and who their manufacturer is and who is legally responsible for them. And this sounds like a massive amount of data, but when you consider that we're going to be able to build a computer that will have the computing power of the human brain, that will have the volume of a bacterium, we really are going to have that type of computing power available to us in the 2020s and 2030s, which is when we would be thinking about starting to deploy this type of a system.
That's amazingly frightening. Having the computing power of the human brain and the size of a bacterium that's synthetically produced, and they are surveilling. I think that this is going to guarantee jobs for Cyber Patrol all the way through the 2020s and the 2030s for their monitoring. All right, this is the last little piece.
The average person should care about nanotechnology because it is the most important technology that will be developed in the 21st century. In fact, you could almost call the 21st century the century of nanotechnology, just as you might have called the 20th century perhaps the century of electricity or automobiles or something like that. It is basically a game-changing technology. It's going to change everyone's lives in almost every way that you can imagine. As to when it will appear, it's going to be another decade or two before the really powerful applications of nanotechnology appear. So people can quite easily avoid thinking about it probably for another 10 or 20 years. But after that, they will have to think about it, and they will want to think about it because it will be so helpful to them. I have a message for my fellow baby boomers. Aging is a disease. It's a curable disease. Nanomedicine is the cure for that disease. We have the resources and the brain power to develop nanomedicine. All we lack is the will to act.
Step up, baby boomers. They want your dollars. They want you to be guinea pig 1.0.
Some people talk about death giving meaning to life. Medical nanorobots really have the potential to extend human life more or less indefinitely, because it's very hard to imagine too many things that could terminate human life that we wouldn't be able to address with with this type of technology. So what's your view about the role of death, and do we need death?
I have no patience for people who say that death gives meaning to life. I believe that life gives meaning to life. And I believe that our intellectual pursuits, our relationships with people, those things are what give the most meaning to life. And you can only experience those through life. Death is something that is an end. It's an end to life. It's an end to progress. It's an end to thoughts. It's something to be cured, not lived with.
Death is to be cured.
I've written how there's an exponential growth of information technology. And of course, we have Moore's Law and even exponential growth before Moore's Law in increasing the amount of computation. And ultimately, we'll get to the point where we saturate the ability of matter and energy to support computation. So some people refer to this sort of ultimately saturated matter and energy as computronium. And ultimately, we'll turn as much of the available resources that we want to without disturbing the biomass and the ecosphere into computronium here on Earth and in this vicinity in the solar system. And then we would have to move on out into the rest of the universe if we want to continue to expand computation. And since computation is going to be supporting intelligent processes, the expansion of intelligence would require that. So could you comment on how you see this developing, this expansion of intelligent processes into the rest of the universe?
Expanding into the rest of the universe. Because Kurzweil not only wants to be immortal, but he wants to be able to be a plague on the rest of the universe. All right, guys, that was about the end. There was only another minute and a half there, and they talked about having to be near the sun or some energy source. So it really wasn't too much. I don't know. Digest that one. I'm going to drop that into chat. That is on YouTube, so I will add that to a reference under the archive once this rips to YouTube. It's titled Ray Kurzweil and Rob Freitas, Freitas, discuss the future of nanotechnology. All right, guys, it's Wednesday, so make sure you stick around tonight. We got Josh live at 6 p.m. Eastern. Continue Condition with Jonathan and Stephen at 8 p.m. Eastern. Truth or Talk, this week's replay at 9 with April and Burstein. And then Anti Media Radio with Nick and DB at 11. All right, guys, wherever you are, I hope you're warmer than we are. 27 degrees, and it's going to be spring this weekend. Damn them. All right, everybody have an awesome Wednesday, and we will catch up with you tomorrow.